In this video, we are going to draw the geometrical or the cis-trans isomers of some of the octahedral complexes. Remember that complexes of the type Ma4b2 or Ma2b4, MAA2b2 or MAA2bc, Ma3b3, MAB3 show the geometrical isomerism, but not the complexes of this type Ma6, Ma5, B. So let us see the first one. An example of the complex of this type Ma4b2 is this one. So where A is NH3 and B is Cl, or we have this example. So let us draw the geometrical isomers of this complex. This one is an octahedral complex, okay? How many coordinate bonds are there? 6, 4, 5, 6. So the coordination number is 6. So hence it is an octahedral complex. We have the central metal ion. There are 6 coordinate bonds. 1, 2, 3, 4, 5, 6. Here also for the cis and the trans. So in the cis form, we have the similar groups on the adjacent positions, okay? So first draw like this. Similar groups are on adjacent positions. Here also NH3, NH3, NH3. So this is your cis form. Whereas in the trans form, similar groups lie opposite to each other. Okay, so these are the two geometrical isomers of this complex. In the same way, you can draw for this one also. So it's a plus like this, okay? So let us come to the second type, MAA2b2. Note that this one is your symmetrical. It's a symmetrical didentate ligand. Example of symmetrical didentate ligand is our ethane 1,2-diamine. So let us draw the geometrical isomers of this complex. Here the coordination number is 6, okay? You should count it 4 here, 2 into 2, 4. With this one 6 because this one is a didentate ligand. We have the central metal ion. There are 6 coordinate bonds. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So here for the cis and for the trans. For the cis, the similar groups lie adjacent to each other. Cl, okay, and then Cl. And then here we have En or didentate ligand. This one, yeah, like this, okay? So this is the cis. You have plus, okay? Plus. And then in the trans, the similar groups lie opposite to each other. En, En. Plus. These are the two isomers of this complex. This one, complex ion, okay? Let us come to the third type, Ma3b3. Example of a complex of this type is this one, where your A is Cl, your Py is B, okay? So the two geometrical isomers of this one, here the coordination number is 6. There are 6 coordinate bonds. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is the cis form and the trans form. Okay, so for the cis form, similar groups lie adjacent to each other. 1, 2, 3. Cl also 3. Okay, whereas in the trans, similar groups lie opposite to what? To each, you can put it here, to each other. Here we have Cl, Cl, Cl. They lie opposite to each other. So this is your trans form. These are the two geometrical isomers of this complex. Now we come to the last one, complex of the type MAB3. This one is your unsymmetrical didentate ligand. So this is an example of this complex of this type. Okay, this one also has coordination number 6. This one is a didentate ligand. So 3 into 2, we have 6. Okay, there are 6 coordinate bonds. Cr, Cr. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This GLY is your glycinato. Okay, it is this one, NH2 CH2 COO minus glycinato. So for the cis form and the trans form, what you do here in the cis form, do in this way, we have O and then the C double bond O, and then we have CH2 and we have NH2 like this. Okay, and then in this corner we have O, C double bond O, CH2, NH2, and in this corner we have NH2, CH2, C, here we have O, okay, and then double bond O. This is your cis isomer. So in the trans, okay, this one, leave it as it is, CH2, C, here we have O, here we have double bond O. Here also leave it as it is, CH2, NH2. Okay, whereas here interchange this one with this. So we have here what? We have here NH2 in this corner, and then we have CH2, C double bond O, and here we have O. Okay, so this is your trans form. Yeah, I forgot to tell you one thing here. This one, these similar groups lie adjacent to each other at the corners of one of the faces of the, I mean to say at one of the octahedral faces here also. So this one is known as facial or fact isomer. Whereas here in this trans one, okay, the similar groups lie opposite to each other, and they lie around the meridian of the octahedron. That's why it is also known as meridional or mer isomer. Okay, so that's all about the geometrical isomers of some of the octahedral complexes.